Good morning. Today we'll discuss about the complete block diagram of a digital relay, and before that we will see what are the components of digital processing subsystem. We have seen that the digital relay basically consists of three subsystems. The first one is signal conditioning subsystem, and next is conversion subsystem, and the last one is digital processing subsystem. The first two subsystems are common for any type of digital relay. The only thing which varies is the third subsystem, which we do call it as digital processing subsystem. We'll discuss in detail components of these in the later units, but let's have a quick block diagram of what this subsystem components are. I hope that by the end of this lecture, you will be able to describe the operation of different components and also list the specifications of standard digital relay units. So first of all, let me start with the components of third subsystem of a digital relay, and we will follow with the common specifications of a digital relay, followed by the block diagram of a digital relay on the whole. So the first one being the introduction. You know that as we have already discussed, the digital relay subsystem, it has both software and also a hardware. And the hardware basically consists of a CPU, a memory, a data input-output devices. And coming to memory, we do have so many things. We do have ROM, we do have RAM, we do have EEPROM, electrically erasable, programmable, read-only memory. So different parts of your digital relay, they will be stored in these things. And coming to the software, it is basically which type of software you are going to use. It depends upon your choice. One is the digital filtering which you want to employ, and the operating principle of your relay which you want to design. So based upon this, software will be selected, and based upon your physical requirements, you will be selecting the hardware. Now, coming to the two important things of software. The first thing is operating principle. Now you know that the operating principle, which coming to in particular, the software selection, the operating principle, it leads to the development of a special algorithm or implementation of an existing. Let us suppose if I want to measure the V and I, and I want to go with the impedance measurement, and I want to operate based upon my impedance. So then you should go with a different design. Let us suppose if I want to go with a differential one, then I am supposed to write a program such that my two currents or two voltages should be compared. So it all depends upon how you are going to use your relay. So either you want a special algorithm or you want to modify an existing one. So this particular factor, it greatly affects determination of sampling frequency, and also the type of hardware structure and the data input which you do require for processing. Some may require frequency, some may require voltage, some may require currents and different samples. So it all depends upon the operating principle. And the second thing which you are supposed to think when you are selecting software is digital filtering, because most of the times you will be having the higher order harmonics will be eliminated through the LPO filter, but here we will be having subharmonics which are unwanted things. So these are to be eliminated, and for this one you are supposed to go with digital filters. Okay, and if you carefully see, the operating principle and the digital filtering must in general provide for a wide application range and requirements relating to very fast speed, very higher speed of response to the system calls. And in particular, the latter one is being influenced by the necessary computation time. Now coming to the software, flowchart for the software of digital active relay. If you see, this is your start button, this is your digital data input, and next you will be filtering the things, lower order harmonics or higher order components, they will be eliminated in this filter. And next you will perform some operation on this digital data. Here comes the operating principles. And next, sequentially, the data is being processed and determination of tripping zone is being done here. And then outputs. So trip instruction is being sent to the circuit breaker or any other component which is there in your physical unit. So this is the flowchart of the software. Now, having gone through this one, coming to the memory also, we will discuss again the types of memory and what will be there in this memory in the class. Okay, coming to the typical standardized digital relay units, the specifications, what the specifications are. You can see that what is the minimum requirement of the CPU, and you can see that it must be a bipolar one with a 16-bit minimum word length, and there must be an assembler language. You must be capable of assembler language understanding. And coming to memory, it requires an IC memory, tap setting, non-volatile IC memory. So these are all the basic specifications. And the reference is here, text of it, which I have already mentioned in the class. And see, this is the representation of a normal digital relay. What happens in practice? See, there are so many data, so many number of inputs which are getting from your power system. See, different phase voltage, different output voltage, different phase currents, and again output current, all are being brought using your auxiliary transformer unit. These are used to step down the magnitudes. And once you get them here, you will be processing each of these data will be processed through filters. This is analog data, right? And next, it is being processed through your sample and hold circuit, wherein you are supposed to move it into digital data. But before to move into digital data, you are supposed to select one by one. So that's why you do require an analog multiplexer here. It selects any one of these data and it gives to your ADC converter. Here, the analog data will be converted into digital data. And here again, you will be having a buffer. And all these things are operated by a clock here. So this buffer, again, it is being connected to your digital processing subsystem, wherein you do have a CPU, memory, data input, data output, and a tap. Now, when I move into this block, it is being processed, and the output is nothing but your trip signal, which is being sent to your trip relay. Okay, this is what happens in your digital relay. I hope you have understood, and we will discuss more about these components in the class. Okay. Now, I hope that now you are able to describe the operation of different components and sketch the entire block diagram as a whole. And I hope that you will discuss about the specifications of standard digital relay units. These are the practice questions, which we will again discuss in the class tomorrow. Thank you.